Hello all, welcome back to Mechans. In this video, we're going to learn about fluid properties. Fluid properties will comes under the category of kinematic properties, thermodynamic properties, and physical properties. Kinematic properties means that when a fluid flows means these properties will consider as a important ones like acceleration and velocity. Thermodynamic properties means it's majorly includes with the heat and how it changes with the heat like temperature, pressure, density and specific volume. Sorry, not specific volume, it's enthalpy, those things. And physical properties means how a fluid looks and how it smells. Those things will comes under physical properties. And further we can classify the fluid properties into two more major categories. This categories is about amount of fluids. If a fluid depends on amount of fluid means if a fluid property depends on amount of fluid means that's a extensive property. If a fluid property doesn't depend on amount of fluid means that's an intensive property. For an example, if you take like 10 liters of water, may weight is 10 kg, assume like that, and the density of the water we know that 1000 kilogram per meter cube, and its temperature is around 70 degree. We consider accurately as 70 degree, and you pour down the half of this water, then your volume would be reduced to 5 liter and weight reduced to 5 kgs, but the density would remain constant, right? Kilogram per meter cube, and temperature would remain constant. So from these observations, if you consider the both initial and final states, we could see that this volume and weight changed because of the amount of fluid reduced, but these properties remain the same. So these properties are called as intensive properties. These properties are called as extensive properties. Intensive properties is furthermore example means like specific volume, specific weight, and specific enthalpy, pressure, temperature. Those things density will comes under intensive property. Extensive property means can take mass, volume, and weight and total energy. Those things will comes under extensive properties. Next, we are going to see about density. Density is nothing but is defined as a mass per unit volume. So, see this figure. This is oil, which has less density than water. The water is under the oil. If we take water is 1000 kilogram per meter cube as density means this must be less than water. This oil density must be less than water. That's why it floats on the water. The same way, if you see the plastic balls floats on the water and the rubber balls floats on the water means because it has a less density than the water. So density is playing a major role in the fluid characters. Density usually we measure with the formula of mass divided by volume, and unit of the density is kilogram per meter cube. And here we mention mass. So what is a mass? It's nothing but amount of substance that fluid has. For example, if you take like 1 meter cube of oil means 1 meter cube of oil has maybe like 900 substance means 1 meter cube of water has more substance than that. Then only the water should have more density than the oil. Why I'm mentioning the mass here is the mass and weight are two different things. The mass, as I mentioned, it's about substance of a fluid. Amount of substance a fluid has, but in volume means amount of force. Sorry, it's not volume, it's weight. Amount of force created by the substance. So mass means just the amount of substance that a fluid has. Weight means amount of force created by those substance. Because if you see this specific weight, it's nothing but it's a weight possessed by a unit volume of the fluid. Here, the mass possessed by unit volume. Here, weight possessed by the unit volume. So weight means nothing but you have to add gravity with that. See, if a person weights, if a person has a mass of, you know, 70 kg means he has a mass of 70 kg. What's his weight in the Earth? Earth has a 9.81 as a acceleration due to gravity. So weight would be 9.81 into 70 kgs. So nothing but uh, m into g. If a person is in a different place, maybe another planet where gravity is zero means his weight become zero because weight is nothing but mass into gravity. Gravity value in that planet is zero. So the whole weight would be zero, but the mass would remain the same. Mass would be 70 kg. So this is what the difference between the mass and weight. Here we saw mass per unit volume in the density. In the specific weight, we are seeing the weight possessed by the unit volume of fluid. It usually comes under m into g since mass is nothing but density into volume into gravity. It's already there. And since we mentioned unit volume, we have only rho and g, that is density and acceleration due to gravity value. Then we comes under temperature. Temperature is nothing but, as we already know, it determines the state of hotness or coldness of an object. It's generally measured by either Kelvin, Celsius, or Fahrenheit. We majorly use Kelvin in calculations. In practical, we use more Celsius, and it's simple that we know. So I don't want to dig it further. The pressure also, it's the thing which we already know. It's like force per unit area. If you take 1 meter square area means how much force is acting on that. If pressure is more means it will create more force on an object. As we know, the general formula for pressure is equal to force divided by area. Then a specific volume. This is nothing but a volume that fluid occupies per unit mass. This is just opposite to the density. Density means what we saw, that how much mass per unit volume. Here we are saying how much volume per unit mass. Specific volume is nothing but how much volume per unit mass. If you include specific in front of any properties means it just has to divide with the mass. So unit of this would be meter cube per kilogram. The pressure we usually by this formula, Newton per meter square is a unit, and we also use bar, which is 10 power 5 Newton per meter square. And the temperature we know, we already discussed. And the one thing about a mass and weight, the unit of both mass and weight are very same, that is kilogram. So the way of understanding the mass and weight is very important. If a substance which needs more volume to create 1 kilogram of mass means that substance has more specific volume. If a, for an example, if one object has 1.5 meter cube to create 1 kg mass means, and if you take another object that is has 1 meter cube volume to create 1 kg of mass means this consider this is A and B. This substance here has more specific volume. If you consider this one, it has a less space to create 1 kilogram. So if you calculate densities, it has more density. So that's why I earlier told that density and the specific volume are two opposite properties. And the specific gravity is an important property that we mainly use it for calculations. It's nothing but the ratio between uh, density of a substance to the standard substance. Standard substance means that nothing but a water. We know the density of water is 1000 kilogram per meter cube, and a ratio of density of substance means if you want to take a specific gravity of mercury means the ratio of density of substance. Mercury's density is 13,000 kilogram per meter cube, and to that standard substance that is 1000 kilogram per meter cube. So specific gravity would be 13.6. It has no units. As I told you earlier, this property is mainly to calculate, used for calculations. If a specific gravity is more than 1 means that a substance has more density than water. If a specific gravity is less than 1 means this substance has a less density than water. So that's all about specific gravity.